Welcome back to 8701. So in the last two videos, we looked at Dirac's equation and we looked at solutions of Dirac equations. And in the last lecture, we found that along with positive energy states, we had those negative energy states. Since we cannot simply drop them or disregard them, we do have to find a physical interpretation for these negative energy solutions. The first one, which was brought forward, is the one where you think about those negative energy states all being populated, and that is your vacuum. The vacuum is basically a sea full of negative energy states which are all populated. So if you have a positive energy state, an electron sitting in this energy state here, the electron, because of the Pauli exclusion principle, cannot fall down into the negative energy state. But you are able to kick them out, for example, to excite them with a photon. So you excite a negative energy state, you get an electron out. So this process is then equivalent to the creation of a positron and an electron pair with a photon, pair production. You can also explain annihilation, where there's an empty and a negative energy state where the electron just falls into creating a photon. So while the interpretation is useful and explains pair production and annihilation processes, they fail to explain what this vacuum, the sea of negative energy state even is. So a more useful interpretation is the one brought forward by Feynman and Stückelberg, which came out of the discussion of quantum field theory. And we already discussed this interpretation when we looked at Feynman diagrams. So have a look at this Feynman diagram here, where you have an electron with a positive energy and an electron with a negative energy building a photon, which is twice the energy in the symmetric configuration of the electrons before. And you're interpreting the negative energy solution here of the electron as the electron moving backward in time. This is an equivalent to a positron with a positive energy and an electron with a positive energy, where the positron and the electron move forward in time. Again, in both cases, you see that the energy of the photon is 2 times the energy of those two particles. All right, so this is a very short discussion, and we will see later on how we use the spinors for antiparticles together with spinors for particles in order to make collisions, calculate matrix element. So we move forward with our discussion of Feynman rules, this time now for spin half particles in QED.